technology that we have. And so what we're going to do today is create some charts and graphs using our technology. First, we need to understand what those charts and graphs are. Okay, so the first one we'll start with is called a stem and leaf plot. So each number is separated into a stem and a leaf. It is similar to a histogram. And if you think about a histogram, it's the one with the bars that are actually touching each other. That's a histogram. If you take a stem and leaf plot and you turn it from its vertical to a horizontal, you can kind of see where you would get the bars of a histogram. Okay, that's why it's similar. It's going to contain the original data values, and it provides an easy way just to sort your data out. Now, we've got a list. There is only going to be one leaf per stem. Okay, so your stem might be, like you see here, 1, 2, 3. Your stem might be 12, and your leaf will be 3. So let's see what that looks like. And just a brief, use the rightmost digit as the leaf. So for instance, 76, 7 would be the stem, the leaf would be 6. 104, 10 is the stem, the leaf is 4. Then you're going to just how to construct it. You're going to list the stems from 1 to 14 on the left of the vertical line, and then you will list out each leaf for that stem. So like for 17, you've got 17, 18 on that top row. And on the second row, you've got 20, 23, 24, 25, 3 times, 26, 27, 29 twice. When you're constructing a stem and leaf plot, it's very important that you put your data in order. Just looking through your homework earlier today, I don't think you're going to need, actually, we are going to construct a stem and leaf plot. I was taking a long time to join. Did I miss attendance? Yes, go ahead and type your first and last name in the chat. And that was how we did attendance for the very beginning. And I'll take kind of a pulse check in between as we go. Aries, I think you just came in. Type your first and last name in the chat. And that is the attendance for the beginning of class. I'm thinking we'll just do it after each break. When we get back, and then I'll be looking at the participation in between as well. Okay. All right. Now, from this display, we kind of get some pieces of information from the data. You can see that more than 50% of the cell phone users sent between 20 and 50 texts. So let's see if I can get my pen going here. Between 20 and 50 texts. That's most everybody in there. Text messages. Is this per day, did they say? No, they didn't tell us. Okay. Another way that you can construct a stem and leaf plot is by having 2 rows for each stem. So one row will have 0 through 4. And the next row will have 5, 6, 7, 8, and 9. So I might have 7 as my stem. And what would be on the first row would be 0 through 4. And on the second row, I would have 5 through 9. And so let's look at what that looks like. I know this might be a little bit harder to see. Can I make that bigger? You would write it twice. So like this number 29, you write 2 9s for 29. And like for 25, there's 3 25s. I'm going to write 5 3 times. And the question there was, if a number appears twice, how would we graph that? We would just list the number twice. The leaf. Okay. So notice I've got on 8, 0, 1, and 4. And then on the second 8, I have the number 8, because on that second row, you have 5 through 9. And this kind of gives us a better picture of our cell phone usage. Yeah, it looks like we're between 17 and 60 is where the majority lies. And then you have these superstars. Somebody's texting 148 texts. I hope this is not per day. Maybe it may be per day. You never know. Okay. Okay, so they said it's between 20 and 80 texts. Most of the data is in between 20 and 80. All right, let's look at question 14 and then question 19. So today I will be going into your homework to kind of look at some of those questions. So if you want to go with me to your homework and look at it there, you can. Where is the homework? Here we go. So 2.2, question 14. So they're going to give you icons to click on, and this is where we're going to get the data to go into StatCrunch as well. But they've given you a dot plot. So real briefly, what a dot plot is that you've listed the numbers on the horizontal axis, and everywhere you put a dot is the occurrence of that number. So like here, let me pop this out. Make it bigger, make it bigger, pop it out. Okay, that makes this a little bit better. So here I have a dot at 70. So 70 is in my data set. And then I have 73. There's going to be a 73 in my data set. 74 is going to be listed 1, 2, 3 times. 76 is also listed 3 times. And then we come here to 81. I have 1 dot at 81, 1 dot at 82, 2 at 83, and 2 at 84. So let's see what they're asking us to do with this. And we're going to get more into dot plots, and that's just a little brief of what a dot plot does and what it looks like. But we need it to fill in our display data in the stem and leaf plot. So given the data that we have, what are our stems going to be? Yes, Michael, go ahead and rejoin. What are our stems going to be in this case? What's going to be to the left of that line? There's going to be a 7 and an 8. So 7, 7, and they said 2 rows for each stem this time. So 8 and 8. So what is going to go in this first box? What leaves will go in the first box? 0, 3, and how many 4s? There are 3 4s. So I wonder if they want us to put a space in between these. I wonder if it matters. We're going to see today. Okay. You don't put commas. What I'm going to see here right now is, do we need to put spaces? I think you just actually just type the number. What about the stems repeat only if specified, right? And generally you only have 2 rows for the stem as opposed to maybe 3 or 4. Generally it's just 2. What's going to be in the second 7? Right, 6, 6, 6. And then the last 8, what are we going to have there? About 81, 82, 83, 83, 84, 84. I don't have anything at 80, so I wouldn't have a 0. Where am I going to start that? Okay, so 1, 2, 3, 3, 4, 4. Okay, 1, 2, 3, 3, 4, and 4. Now I put spaces. Let's see if that's what we do. Check answer. I want to do this question again. Will it let me? Yeah. Oh, shoot. Didn't mean to do that. Is it going to be the same? It's not going to be the same. Oh, you know what? I wanted to do this again because I wanted to see. Okay, do that. If we can just put it without the spaces. So we've got 71. We got 7, 7, 8, 8 again as our stems. 8 and 8. And then for the first one, 1, 2, 71, 71. So 1, 1, 3, and 74. Because remember, the first of 2 rows is going to be 0 through 4. So in this case, I'm just not putting the spaces because I want to see if it's going to throw an error for us. All right, in the next one, I've got a 75. So 5, a 76, 6, and a 77. 7. All right, so what am I going to put in this first 8 slot? I will ask you instead of giving you all the answers. 0, 0. 1, 2, 3, 4. All right, here goes. No spaces. Okay, so with the stem and leaf plot, when you're doing them in the system, it doesn't matter if you put spaces or no. So you don't have to do the spaces. Okay, that is how we construct a stem and leaf plot. And then there's another question for you, but we will keep moving. So we talked about a dot plot briefly, and we looked at our dot plot. So I think we kind of got that one down. Any questions on the dot plot?
Yes, I have
Sure.
a question.
Okay.
So when starting the dot plot, we're starting where the first dot is. That's showing like on the graph, like at 21.
Uh-huh.
That's where we start our leaf.
So your stem, yeah, your stem would be 2 and your leaf would be 1.
Okay, just making sure.
Mm-hmm. Okay, so they want us to use a dot plot to organize this data in example 1. I'll just show you what it looks like because if we had a lot more time, then we could construct this dot plot, but we don't. So, dot plots. StatCrunch also does dot plots, but when I was looking at your homework, you are not going to have to use StatCrunch to create a dot plot. Let me just show you real quick. Anyway, in StatCrunch, you'll go graph and then dot plot. Now it's going to ask you, where's your data at? And we don't have any. Let me see if I can grab some data real quick. What was the other data? Here we go. I'm just going to do a few of these. I'm not going to do all of them. All right, now I'm committed. I guess I'm doing all of them. Okay. Give us a data set. Graph. Dot plot. You're going to select the column that the data is in. And there's your dot plot. If you hover over the dots, it tells you which dot that is, what number it is. And you'll find in StatCrunch with your graphs, if you hover over the graph, it's going to show you or tell you what the frequency is. It'll tell you, oh, that reminds me. And it will tell you, kind of give you information about that particular part of the graph. Now, your 2.1, well, 1.1 through 1.3 and 2.1 are not due until September the 14th, right? And that is Sunday. So I wanted to tell you, if you hadn't gotten to 2.1 just yet, let me hightail it back over to Canvas. Oh, it's going to make me log in. Is my login already here? Oh, of course, two-factor authorization. Let me in. All right, great job. Okay, done. Let me in. Thank you. Goodness gracious. Okay, security. Okay. Under course materials, no, modules. Sorry. Okay. I have placed the presentation for Unit 1. I have placed a little video here for question 7 on 2.1. When you open it up, it opens up in that stream video, and you might have to log into TCC with your login in order to see it. But just a little bit is the ATM problem. If you haven't seen it yet, there's some help for you right there. And I don't remember who reached out to me about it. I don't remember if it was from this class or from my other statistics class, but I put it in both classes just because we both, you know, we might need the help. And with that being said, if you have any trouble with any of the questions, feel free to send it to me. It's nothing for me to get on Teams and make a video and show you how to do it. Okay, and that I don't mind doing that at all. Okay, so we covered dot plots. Hooray! Now we're going to get into pie charts. Pie charts. Pie charts provide a convenient way to present qualitative data. Qualitative data. Remember, qualitative data is qualities or characteristics. And so we're talking about frequencies here, okay? Frequencies of a categorical variable. So again, it's a circle, and you've probably seen these before way back when you were in school, not way back for some of you, but for some of us, way back. I'm included in that, so don't Don't think I'm talking about anybody. So constructing a pie chart. You can also do this in StatCrunch. They have the types of degrees from 2019 in thousands. And we're going to use a pie chart to organize the data. Now, to construct a pie chart, remember it's a circle, so you're going to have pieces of the pie that are a percentage of the circle. So what you would have to do is multiply whatever that relative frequency is by 360 to get how much of the circle it's taken up. Okay, let's look and see how we do this in StatCrunch. I probably should delete out this other stuff here. Hey, this is where I want it to be. Started typing in the wrong one. All right, so 1037, 2013. And if you're calculating these by hand and you're doing your pie chart by hand, yes, you will need to calculate the relative frequency so you can find that angle. The relative frequency is what you'll multiply by 360 to get the angle of that particular piece of the pie. But in this case, when you put it in StatCrunch, you don't have to find the relative frequency because it will do that for you. So graph pie chart with summary. And the categories are in var 2. My counts are in var 3. Those are the frequencies. So again, it gives me the data on the right side, but I can hover over each part of the pie and see that associates is 1037. Bachelor's is 2013. And then we have here doc and masters. So that's how you represent those. And we checked it using technology. Next chart we have, and if I'm moving too fast, let me know, but pie charts are one of the ones that I know we've been exposed to before. It may be a little bit of jogging of the memory, but that's why I'm not going to hover around with pie charts too long. Plus, we have 4 sections to get through tonight, and I want to make sure I give you all the tips and tricks you need to conquer the questions. All right, so a Pareto chart, like Dorito, Pareto. A vertical bar graph in which the height of each bar represents frequency or relative frequency. The bars are in descending order with the tallest bar on the left, and it goes down toward the right. And so we have these different accidents, cancer, chronic lower, leading causes of death. We're going to use a Pareto chart to organize the data. So on our Pareto chart, heart disease is going to be first because that has the highest frequency. See there? Heart disease has the most, and then you have cancer, then you have accidents, chronic lower respiratory diseases, and then stroke. StatCrunch does Pareto charts too. And we can make one graph, bar plot with summary, categories in var 2, counts in var 3. So in order to get a Pareto chart, you have to do count descending where it says order by, okay, and computing. So bachelor's is first, associates, master's, and then doctoral. So a Pareto chart is like a bar graph, or in StatCrunch, they call it a bar plot. It's like a bar graph where the bars are in descending order. So let's look at question 10. Yes, I want to leave. Okay. So here is a question that has this double window on it. The double window indicates that you can open it and then open in StatCrunch. Open the data, 76 metals. Now, okay, A is 37. I was looking for the letters. In this case, I have to put the letters on here. C was 117, D was 61, E is 76. Graph bar plot with summary. My categories are now in VAR 2. And then my VAR 1 is where my counts are in. And again, for a Pareto chart, you do count descending. Again, if I hover over the bars, I can see that I got each one of those frequencies. I can see your comment there when I go to do the attendance and do the participation as well, Sarah. Okay. And that, notice C is first. So we're going to choose C, not choose C, but choose the one that has C first. And so that is that one. Some of these questions in your homework are pretty straightforward. Country C won the greatest number of medals, and country A won the fewest. And that's a Pareto chart. Let's look at 16. I don't want to spend too much time on the homework, but I do want to do it. Okay. So it's asking us to go from a pie chart to a Pareto chart on question 16.
Professor,
Uh-huh.
I think somebody asked, how did you get the part where you say ascending?
Oh, okay. Thank you. Let me go back to StatCrunch here. In options, when you're selecting, you go order by and count descending. In the order by part. And then compute. Okay, perfect. Thank you. Yes, because I'm floating in between screens, so I don't always see the chat right off. So thank you for that. Okay, so for this one, I'm going from a pie chart to a Pareto chart. What is going to be the correct bar graph or the correct Pareto chart for the data? SP is spring and S is summer. So summer, 35%, and then you said A, so spring is next. Okay, then fall, then winter. Perfect, A. And then they ask you a question just to interpret there. So that is Pareto charts. I think we're done with Pareto charts from here. All right, the next thing we're going to do is scatter plots. Whenever we have ordered pairs of data, we want to use a scatter plot. So maybe you want to chart height versus age and height. That would be a good one for a scatter plot. Sometimes we do age and shoe size. It just depends on whatever you want your two variables are. And we'll see what those look like. So we've got this situation here of petal lengths versus petal widths. So they have a data set that has the petal lengths and the petal widths, each listed 2 points, 2 numbers for each data entry. As the petal length increases, what tends to happen to the petal width? Let's look at the scatter plot. So like here at the very bottom, this would mean, this little dot means there's a petal length of 10 and a petal width of about, I'm going to say 2. Let's get this pen going here. So let's say this is about 2. And the petal length is 10. So each point represents 2 numbers or 2 values. Now, what is happening as the petal length increases? What is happening with the petal width? What do you think is happening there? So as I move to the right on petal length, what is happening with the petal width? Right, it's also getting larger. It's also increasing. Okay. Let's look at 2.2, question 12. Yes, I want to leave. Okay. Again, we have somewhere where we can pick up the data. So let's pick this up. I click on the icon for the data table and then open in StatCrunch. Graph, and this time we want a scatter plot. Scatter plot, the X variables is going to be students per teacher, and the Y variable is going to be average salary. And compute. Now, one trick here is what I do, I look at these boundaries here. Like if you notice at the bottom, it goes from 10 to 20. Do that back there. So in my StatCrunch screen, this little hamburger, I can click on that and I can go to X axis and change my minimum and maximum. You can do that for the X axis, and the Y axis goes from 25 to 55. So you can also change the Y axis from 25 to 55. Now I can go in and compare, what does this graph look like? Which one of these graphs looks like this? And it's much closer to what you're going to see. You got D. Yeah, I got lots of D's. Agreed. And then let's do this question. Describe the relation between students per teacher and average teacher salary. Well, we're going to get into scatter plots. Hold on, the dogs might bark. We're going to get into scatter plots a little bit later. I think actually next week. A little bit deeper. But when you have points that are like all over the place, that means that there's no relationship. So this is going to be, there appears to be no relation between students per teacher and average teacher salary. It would be nice. I've had classes where I've had 50 students, 50. And I made the same amount of money that I made whether I had 20 students. So next graph. Any questions on scatter plots? See, it's crazy. Again, we will get into more of the scatter plots next week. But at least you know how to construct one. All right, so a time series is going to be a data set that's composed of quantitative entries taken at regular intervals or over a period of time. And then you can see there's a little graph down at the bottom right. That's what a time series chart is going to look like. And they've given us years on the left, and then they've given us burglaries and robberies. So which one are we going to chart here? We're going to construct a time series chart for the number of motor vehicle thefts. Describe any trends. Okay. It says motor vehicle thefts. What's the difference between a burglary and a robbery? Okay, so maybe they meant burglaries. So apparently burglaries are what we really wanted here. And I'm going to plot 2009, then 2.2, 2010 and 2.17, 2011 and 2.19. Let me show you how to do this in StatCrunch because I think you're going to have a question like it. Let's see. What question was that? Question 13. Oh, we were on 13. All right. So we want to use a time series. Again, a time series is going to have the years listed on the bottom and the frequency on the right or the left. So I'm going to go ahead and open this in StatCrunch. This is called an index time plot. An index time plot. In the select columns, I'm only going to select degrees. And I'm going to go time and year. And I'm going to start with the year 2008. And it's incrementing by 1 year at a time. So I'll just leave the 1 there. But if you're incrementing by something else, then you can definitely put that number in there. And here's what my graph looks like. Again, you can adjust the y-axis looks like. Let's see what the y-axis is on MyMathLab. The y-axis goes from 70 to 110. But do we need that? Trying to get them both on the same screen at the same time, but I'm clicking on the wrong button. So here's this, and here's our StatCrunch. Yeah, we don't necessarily need to put the axis here, but I'll do it anyway because I told you about it. Yeah, it's A. It's A. All right. Okay, and we have another 741, another interpretation question, and so I'll leave those to y'all. I'm really wanting to show you some of the technology pieces of this as well. But that ends 2.2. 2.3 is going to be about measures of central tendency. So let me pull that up and we'll get started on it. And that will take us into the break. We'll see how far we can get.
Professor Porter?
Sure. Uh-huh.
Can you do that graph again, please? When I'm trying to do it in mine, it just says that I must select at least one value. I'm not sure where I'm messing up at.
Sure, let's go here and here. So you have it looks like this, the data.
Yes.
Okay. So let me go back to options and edit. And so under select columns, it's just degrees.
Oh, okay, that's where I messed up. Okay. And why do
Okay.
I have to click degrees again and not year, or how do I?
So year is already captured down here at the bottom.
Oh, I see. Okay.
And we really didn't need to have the year column here, but it's just in case we were going to graph it by hand, we have the year column.
Okay, cool. Thank you.
Uh-huh. All right, central tendency, measures of central tendency. So a measure of central tendency is going to be a value that represents a typical or central entry of the data set. This is going to be review for you. The most common measures are mean, median, and mode, and we're going to kind of go over those three. All right. So the mean is going to be the sum of all the data entries divided by the number of entries. We use sigma notation to indicate addition of all of those entries. Sigma notation means I'm going to add up all the X's, and I'm going to show you on the next screen what that looks like. Now, most of you know how to calculate an average. So you're going to add up all the frequencies and then divide that by the number of frequencies that you have. That N is the number of data entries that you have. And then let's look at this example that we have. So in this case, what we would do, we would add up 274, 235, 223, and so on, and then divide that by the number of entries we have. So we've got 1, 2, 3, 4, 5, 6, 7 entries. We will divide that by 7. So the summation of the X's, or the summation of the data points, is going to be 1810. And that E means summation. And then to find the mean, we will divide that 1810 by 7. And we get 258.6. I'm going to go all the way through to the mode, and then we will go to StatCrunch and see how we can do this in StatCrunch. The median is going to be the middle of your data set. So that means you have to order your data set from least to greatest, and then find the middle. Now, there's two situations here. If you have an odd number of entries, the median is going to be the middlemost data point. If you have an even number of data entries, the median is going to be the average of the two middle points. So we want to find the median of our little data set. Okay. We got to first put the data in order. Then we got 1, 2, 3, 4, 5, 6, 7 data points. It's odd, so I want the middlemost point. So here, the middlemost point is going to be 268. Now, let's take out the person weighing 285 pounds. What is the median weight of the remaining adults? Well, now I have an even number. I'm going to have to take the average of the two middle points. That was already ordered. And so the median now becomes 251.5. The mode. It's the data entry that occurs the most. You can have 2 modes. You could have 3 modes as long as they occur the most. What is the mode of our little data set here? The one that occurs the most. Yeah, you got it. 235. Okay. So now let's take this back to StatCrunch. 1, 2, 3, 4, 5, 6, 7. And I need my PowerPoint here. This. Okay. I'm just going to put them in var 3. And I didn't mean to put them in order because I wanted to show you how to put them in order yourself. Okay, I'm in var 3. Let's get rid of that graph. So here you can sort the table ascending, even though that I already entered them in order. If you need to put data points in order, you can just sort ascending with this little arrow pointing down. So you'll do stat, summary stats, columns. And I'm in var 3. And what I want is the mean, the median, and the mode. So I'm just going to select the mean, the median, and scroll down the mode. And you can do that on a PC by holding down the control key and selecting each one of those. And then I'll select or click on compute. And notice here, it gives us the same numbers that we got in the PowerPoint, 258.6, and then 268 was the median, and the mode is 235. Now I want you to be careful with this because in StatCrunch, if there's more than one mode, it's going to tell you that there's multiple modes, but it won't tell you what the multiple modes are. So just keep that in mind. All right, we are at the 50-minute mark. So let's take a 10-minute break and come back at 8 o'clock. And we'll continue this conversation. And of course, we'll walk through that again as well. Let me find a timer. Not that window. Not that window. Again, this. And this. All right. And we were on 2.3. I know it doesn't. Okay. Let's get back to where we were. Question 8, question 9, question 10, question 11. Let's look at these questions. Question 8. Oh, I'm on show completed. Didn't mean to do that. Okay, so just a brief review of how we got to StatCrunch and the mean, median, mode in StatCrunch. I'm on question 8. I click this double window, open in StatCrunch, and it opens up the data in StatCrunch, right? Then I go stat, summary stats, columns, and var 1. var 1 is where I have all my information at. And most of the time, especially like during a quiz or a test, you can just load the data in straight from the question itself. Whoa. Need my options here. Here we go. And I just want the mean. I'm going to need the median and the mode, compute. So I got all of them, even though it's going to ask me a couple of questions. So the mean is 10.185. It has a mean score, and it says round to 1 decimal place. 10.18 goes to 10.2. Check the answer. Does the mean represent the center? Yeah. Check the answer. What is the median score? What we get? 9.9. 9.9. How many data points? There's 1, 2, 3, 4, 5, 6, 7. So I just counted here, but you don't need to do that because look in StatCrunch, you can see where it says row, it gives you the row, how many rows you have of data. So, all right, 9.9. Does the median represent the center of the data? Yes, it does. Okay. And what is the mode? I think it gave us 9.6. Answer. Now, does the mode represent the center of the data? 9.6. Let's look. 9.6 is not necessarily the center. Let me put this in ascending order. Yeah, it's not necessarily the center. I wouldn't say that either. Let's see what are our choices. All right, so which one is it? A, B, C, or D? Because we said it doesn't represent the center, but what does it? Which option is going to work for us? This is the smallest. Try C. Remember when with your math lab questions, a lot of people are thinking C. With your math lab questions, you can always do them again. Yay, nice work. We did it. 9. There, number 1, I'll look at. Question 9, question 10, question 1. Okay, let's move forward. At a political debate, a sample of audience members was asked to name the political party to which they belong. Their responses are shown in the table. What is the mode of the responses? What is the mode of the responses? What do you think? Remember, the mode is the one that occurs the most. Is it going to be Democrat, Republican, Independent, or other? Don't know.
Democrat.
Democrat. You are correct. You would be right because it has a frequency of 46. All right, so all three measures describe a typical data entry to the data set. One of the advantages of using the mean is that it takes into account all of the data that's in the data set. A disadvantage of using it is that it's affected by outliers. So if you have a point that's much higher than the rest of the points, it's going to pull that mean toward that high point. If you have a point that's much lower than all the other data points, it's going to pull that mean toward that data point. And we'll see what that looks like here. So notice I have in my table all these people in the 20s, and then I have one person that's 65 in this class. Well, let's calculate the mean. That's going to be 23.8. Now, what I like to do is I like to see 23.8 is going to fall right about here. It was Sunday. Okay. Well, we're rocking and rolling today. 23.8 is about right there. Let's look at the median. 21.5, that's about right here. And then the mode is the smallest point in the data set. So which one do you think represents the center? Which one do you think represents the center? The mean, the median, or the mode? I got a lot of medians. Let's check it out and see. Well, it is the best representation of what the average is, but which one is going to be a typical data entry? And so I got a lot of medians, and in this case, it is going to be the median, because what's happening with the data set is that that 65 is pulling the mean toward the 65. That's why in this other slide right here, that's why we could see that we're at 23.8, which is kind of at the top end of our data set. It's not necessarily the middle. So in this case, it would be the median. Okay. So that's mean, median, and mode flat out. We also have something called the weighted mean. And you probably experienced this with your grade point average. So with your grade point average, that is a weighted mean. So how do we calculate it? We take the summation of X times W, where W is the weight of each entry X, and the summation of the weights, and divide it by the summation of the weights. So here are our grades. It tells us the credit hours, and it tells us the system assigns points as follows, and A is a 4, B is 3, C is 2, D is 1, F is 0. And that's a real grading system. So what I'm doing is taking my X value, my 2 points, and this was the C, D, A, C, and B. Is that what we had? Yeah. We're taking those point values and we're multiplying them by the credit hours, which is the weight, 3, and get 6. We do that for each of the points, and then we add up their products together, and we get 40. The summation of the weights is 16. So 40 divided by 16, this student has a 2.5 GPA. Okay. Check and see. Let's look at question 13 and 14, 2.3. Okay, so the system for finding a weighted mean is pretty straightforward. It's not too hard to capture, but you can also do it in StatCrunch. So I'll show you how to do that. So I did an open in StatCrunch. The student's weighted mean score is, so stat calculators custom. The values are in score. The weights are in the percent of the final grade. I'll hit compute. So our weighted mean score, I know it gives us a graph and everything else, but our weighted mean score is 94.75, and we're rounding to 2 decimal places. Is there anything else? Oh, okay. Now, on this question, I'm bringing it up here so you can kind of see the strategy. see, can I write on this? Ooh, let me get to my Teams window and see if I can. It's not going to let me write on that. Let's go back to it. So I need a sheet of paper. Just open up a piece of paper and oh, it says you have a checking account. It has a balance of 530. Oops, well, what happened there? 530 for 23 days. Those are my weights. And it has 2330 for 4 days. And then 221 for 3 days. So you can follow that same process of entering that into StatCrunch. What's the account's mean daily balance for April? Let's get back to StatCrunch here. I'm just going to put this in VAR 4 and 5. 530, 23, 330, 4, 221, and 3. Oop, 3. So now stat calculators, and this is a custom calculator. The values are in VAR 4 and my weights are in VAR 5. And I'll hit compute. So my average daily balance is $739.10. So I will enter that here. What is the account? 2 decimal places, 739.10. Okay. Now we're going to do the next thing. Weighted mean. Any questions on the weighted mean?
Could you do it again with the calculator one more time, please?
Yeah. Let's go to stat, calculators, then custom. The values are in, for this last one that we did, VAR 4. And the weights are in VAR 5. And then compute. And the mean they give you is down here at the bottom. Okay, cool. So 2 homework questions down at least. And what, 16 more to go? How many do we have in here? No, 20 more to go. Okay, let's jump into the mean of grouped data. The mean of group data. So in this case, we're going to have to calculate some midpoints for some of them. Well, all of them, where X and F are midpoints and frequencies of a class respectively. So let's look at this. To find the midpoint of each class, you're going to add together the lower and the upper limit and divide by 2. Then you'll find the sum of the product of those, the midpoints and the frequencies. And I'm going to show you what this looks like in a problem, because sometimes when we go through like the wording of it, it doesn't really quite make sense. But when you put numbers in it, it's like, oh, okay, that's what they mean by that. And then we'll find the sum of the frequencies, and then we'll divide them by each other. Okay, so in this case, they have already calculated the midpoint of the class, and that's going to be the lowest plus the highest divided by 2. And then the frequency of that class is 3. So I'm going to multiply those 2 together, and I get 517.5. I'm going to add all of those products together to get 8631. And then I will divide by the number that I have in the data set, which is 30. Okay. Question 15. Let's look at that one. All right, so, and also 16, 17, and 19. Let's tackle 19. I think. All right. So I believe we can do this whole thing in StatCrunch, but let me check this out. The class width is going to be the largest plus the smallest, excuse me, the largest minus the smallest, and divided by the number of classes. And so we have 5 classes here. Let's put this in order to see what the smallest and the largest. Okay, I remember why I wanted to do 19. It's because it actually brings in the stuff that we learned last week. So to find the class width, we take the largest, which is 76, and we subtract the smallest, which is 62. So 76 minus 62 is 14, right? Am I right? 76 minus 62, 14. And divide that by 5. Oops. Thank you. You know, I don't trust myself. I told you last week, I don't trust myself with simple addition and subtraction. But I should, being a math teacher, right? All right, so we'll take 14 and we'll divide that by 5. And what do we get? It's 2 point something, right? We're going to round up to 3. Thank you. 2.8 and round up to 3. And so we'll start. It says use the minimum data entry as the lower limit of the first class. Okay. So the minimum data entry was 62. And then we're adding 3 every time. And the class for use the minimum data entry. And we're going to go to 76, 68, 71, and 74. And then we just fill in the other side. You remember how we did this last week? Is it coming back to you? A little bit, maybe? It's just one, yeah. Yeah, the upper limit is just one less. And so we can figure out now what the midpoints are, because if you think about the midpoint is the middle, right? So 62, 63, 64. The middlemost point is 63. And so in this case, the middlemost is just going to be the number that's in between the 2. And then we need the frequency, and we'll get that from StatCrunch. The frequency of 62 to 64 is 4. The frequency of 65 to 67, 1, 2, 3, 4, 5, 6, 7 is 7. And then I'm just counting them up. 68 to 70. We got 1, 2, 3, 4, 5, 6, 7, 8. Then 71 to 73. 4, 5, 6, 7, 8 again. And then 74 to 76 is just 3. Fingers crossed, all that is correct. Let's check it. Okay. All right. Now they're asking us for the histogram. Dun, dun, dun. Well, I mean, you could look at what you have here. Like at 63, you're at 4. So that's here. And what else? Oh, there's only one. There's only one. There's only one graph. Yeah, there's only one graph where 63 has 4. But I think, let me get my steps. Histogram, bins, and we'll start it with histogram. Let's go look at this graph. Histogram, heights, and bins. We're going to start at 62, and the width is 3. This is how we graph these particular problems in Compute. So you can kind of see it does match back to A. And we haven't talked about skew yet. I think that's next. All right. I say thank you for that. So we're going to talk about the shape of distributions. I know we kind of came off of the weighted mean, the frequency, the mean of a frequency distribution. We calculated some midpoints, and you're going to have to do those in your homework as well. Sometimes the midpoint will be the average of the 2 middle points, like in the median. So basically, you're taking the median of a class. The reason I'm saying that is because I was thinking about one of these other questions. Yes, I want to leave. Which one was it? 17. So like from 0 to 19, that's 20 numbers, right? The middle is going to be like 10.5 or 9.5. 10.5. Again, I got 19 divided by 2, 9.5. There we go. The middle is 9.5. And then you can just add 20 to that because they're adding 20 each time to get to the middle of the next class. And that's why I was mentioning that the middle is going to be the average of the 2 middle entries. Okay. Now we get into shape. Okay. So the shape of a distribution. First one we have is symmetric. That means the halves are mirror images of each other. I guess I can do this. The halves are mirror images of each other. A vertical line can be drawn down the middle, and the mean, the median, and the mode are the same. That's a symmetric distribution. We also have something called a uniform distribution. And that's where all the entries have approximately equal frequencies. I'm saying approximately because what you're going to see in your homework is that they're going to vary a little bit. It might be something like this and this. It's not gonna let me do it. They might be really close together, like this. So that we would consider that to be uniform as well. It's also symmetric. Now, this is where you might not have heard or what might be new. A distribution that's skewed left or negatively skewed means the tail, you trail off to the left side. So there are more larger values than smaller values. There's more larger values here than smaller values. And notice the mean is going to be to the left of the median. And the mode is going to be to the right of the median. And again, you can get these slides from inside MyMathLab. They're there. When I say skewed left, the skew is in the tail. That means it trails off to the left. So that means when I'm skewed right, I trail off to the right side, meaning there's more values that are lower than those that are higher. And in this case, the mode is on the leftmost, the median is in the middle again, and the mean is going to be on the right when you have a right skewed distribution. Because remember, those far out values, that's where the mean is being pulled to, those far out values. So this is telling us with right skew that I have some values that are far to the right or much higher than the rest of the distribution. Okay. Let me see if there's a question that I wanted to look at based on that. We have a lot of them. Let's choose one. Question 6. Here is an example of what I was telling you earlier. This we would consider to be uniform. And then again, you can pop this out if you need to look at it in a bigger way, or you can just enlarge it where it's at. And we would consider that to be uniform. And why? Because the bars are approximately the same height, approximately. They're not necessarily the same height. Let's see, question 7. Okay, here's one where there's going to be a skewed distribution. It says construct a frequency distribution of scores on a 110-point test where a few students scored much lower than the majority of students. A few students scored much lower. What do you think that would be? Left skewed, right skewed, or we got an A's to 831? We got a left skew. And I'm thinking to myself, I got lots of A's. Let's try that. I'm thinking to myself, though, if you look at the axis, only one of them has an axis that reflects this 110 points, 110-point test. Huh. So that one was kind of a gimme question there. All right. So you're going to have a few questions where you're going to have to determine left skewed, right skewed, symmetric within your homework. And let's skip over to 2.4 because 2.4, I believe, is much longer. And I'm going to show you a lot of the things that we're going to do in technology with 2.4. So I'm going to get rid of 2.3. Any questions on 2.3 before I move forward? Okay. So when you say right skewed, the left side has more data points, right? And then you are meaning that a certain side has smaller data. Yes, yes. So right skewed, the right side has less data points. Left skewed, the left side has less data points. Does that make sense? Okay, cool. Let's get rid of that. And now we're in 2.4. 2.4 is a long one, so let's get it started. Oh. I'm showing my age. Anyways, let's start with what we're going to find. We're going to find the range of a data set. We're going to find the variance and standard deviation. We're going to use the empirical rule. We are not going to do Chebyshev's theorem. There was one question on your homework based on Chebyshev's theorem, and I went in there today and just replaced it with a different question because I don't want to get into that. We're going to learn how to approximate the sample standard deviation for group data, and then learn how to use the coefficient of variation to compare variation in different data sets. So we got a lot to cover in this section. Hopefully we'll get through most of it before 8:50. Okay, the range. The difference between the maximum and minimum data entries in the data set is the range. The data has to be quantitative. And when I say the difference, it means the maximum minus the minimum. What is the range then of I'm just looking at the chat. Corporation A. What's the smallest? What's the largest? And then subtract them from it. Subtract the minimum from the maximum. Yeah, the minimum was what? 47 and the maximum was 57. So yeah, it is 10. While we're here, what is the range of Corporation B? What's the maximum? 68 and the minimum is 33. Oh, that's a bigger range. So these are starting salaries for a corporation in the thousands of dollars. So we're going to kind of see how we can look at this in the real world. We already figured it was 10. The range of the starting salaries for Corporation A is 10,000. Okay, and they're telling us both data sets have a mean of 51.5 or 51,500. Yet the two sets differ significantly. Why? Because there's such a greater variation in Corporation B starting points than Corporation A. Which corporation would you want to start working for? What do you think? A or B? Which one would you choose? Got a lot of A's. Nobody wants to work at Corporation B. You could possibly start out at 65.5. Now they've got a higher, but I think a lot of the reason why people are selecting A is because you're much more guaranteed an income between the 47.5 and the 59.5 at Corporation A. In Corporation B, you go from 35.5 to 65.5. That's a big difference. Yeah, the frequency is higher at 53.5 on Corporation A. Yeah. Okay. So that's kind of our lead in to what variation is. A deviation now is going to be the difference between a data entry and the mean of the data set. And so this is what it looks like. The data entry is X and the mean is the mu. This symbol here, this is the mean. And then for a sample data set, of course, this X bar is the mean. Now, I'm going to show you a lot of calculations, but I'm not going to expect that you're going to do all those calculations because we kind of have limited time when you're taking tests, when you're doing the homework. You know, we have lives, we have jobs. There's a reason why you're in weekend college and taking a class from Friday night from 7 to 9:50. And it's probably, most of you is probably because that's what fit into your schedule, right? So we don't have time to be doing a lot of the some of those calculations here. Just a preface of what's to come. So we have something called the population variance. How does the population vary? And then this population standard deviation is going to be the square root of the population variance. And these are the two formulas. Notice I have the summation of all of the deviations squared. And I'm going to show you a table of what this looks like so you're aware. Okay. Just some observations about the standard deviation. It measures the variation of the data set about the mean and has the same units of measure as the data set. It's always going to be greater than or equal to 0. If the standard deviation is 0, then there's no variation at all, and all the entries have the same value. As the entries get farther from the mean or more spread out, the value of the standard deviation increases. Now, we're going to what the rules are to finding the population variation and standard deviation. You're going to find the mean of the data set. And then you're going to subtract the mean from every data point. And then you're going to take that value and square it. And then you'll take all of those values and add them together. That's the summation. This SS is sum of squares. Then you divide by n. Okay, let's see what that looks like. Now, what we found here is the mean of a data set for Corporation A. It was 51.5. This is what they mean by subtracting the mean from every data point. So this is what they did here. Take the data point 51, subtract the mean. Take the data point 48, subtract the mean. You can see where it's very easy to kind of get lost in the calculations. If you're off on one thing, you kind of make the whole thing off. Oops. Hold on, I lost my window. Okay. Now, what we're going to do is now take the square of each of those. So I'm going to square, I got negative 0.5. I'm going to square that to get 0.25. And then I'm going to add all of those together to get my sum of squares. Sum of squares, previous screen was 88.5. So 88.5 divided by 10. That's the number of points in that data set. And my variance then is going to be 8.9. Well, we're going to take the square root of that to get the standard deviation. And so the standard deviation is about 3 or 3,000. Sample variance, the only difference between that and the population variance is this n minus 1. So instead of n, we have n minus 1. Same process, but instead I'll divide by n minus 1. And then to get the sample standard deviation, I'm going to take the square root of all of that. Now, let's try it. What is the situation here? In a study of high school football players who sustained concussions, researchers placed the players in two groups. Players that recovered from their concussions in 14 days or less were placed in group 1. Those that took more than 14 days were placed in group 2. The recovery time in days for group 1 are listed below. Find the sample variance and standard deviation of the recovery times. Okay. How do you do this? This is the sample. This is a sample. Let's pull up. Let's go over to the homework, and this is 2.4. I'm just going to open up a question so I can open up StatCrunch so we can kind of look at this data set. Eight, 10, 6, 7, 7, 9, 10, 7, 6, 5, 11. Okay. So remember what we went through before when we went summary stats, columns, bar 1, and I want the mean, the variance, and standard deviation, and compute. So let's go to our calculations here, make sure. We have 4.6 is our variation. 7.5 was the mean. Okay, I was looking for the mean on the page. 7.5, there it is. There's the mean. And then the standard deviation is 2.2, or what we got was 2.15, and they just took it to one decimal place. So you can get this information from StatCrunch. Some of these tools and scraps be available. Yeah. You can do the same, like I'm doing the open in StatCrunch with the double windows. You can do that. I believe the last time I looked at a test, StatCrunch was like another tab within the test itself. But yeah, these tools are available during the test. Because if they weren't, okay. You're welcome. Yes. So if you use a TI-84, you have to enter in all the data yourself, and then get my calculator here. My calculator. Okay. So What I'll do, I think I have a cheat sheet for statistics and the TI-84, the steps to do things on the TI-84, but you'll mainly be in your stat menu and under calculate, it says one var stats. So one variable statistics, you would click on that. You have to create a list and then you click on the stats and calculate. Yeah. So remind me via email to get that cheat sheet and post it in the class somewhere. If it's not already posted, I'll point you to where it is. But yeah, you can do all of this on TI-84. Okay, so see here, they've done this on the TI-84, and I'm not going to put all these data points in, but they're just showing you can do this on Minitab, Excel, TI-84, and StatCrunch. Okay, understandable. Okay. So the standard deviation is a measure of the typical amount of an entry deviates from the mean. How far away from the mean is it? Okay. So like we were saying, a standard deviation of 0 means that all of the data points are the same. A standard deviation of 1.2 means you're not really that spread out from the mean of 5. But if you have a standard deviation of 3, you're kind of spread out there if you're talking about a mean of 5. Oh, it's 8:50 on my clock. All right, pause. We were talking about some different standard deviations, and I put my glasses on. My read does. Okay. What do you think the population standard deviation is of number 1? That's clear. What do you think the standard deviation is of number 1? Give me a number. Got a 0, another 0. So every entry is the same. There's no deviation. There's no deviating away from the mean. The mean and the median and the mode are all the same. What about number 2? What about number 2? What do you think that standard deviation is? Oops. The answers there. Yeah. It's about a 1. Because the mean is about 4. So 1 standard deviation away. Okay, what about the standard deviation of number 3? What do you think that standard deviation is? For 3, would it be 2? Let's see, what do we think? What do we think? You're going from 1 to 7. And the middle is about at 4. Okay, let's see. Close, very close. It's a little bit greater than 2. So the mean is 4. The deviation of the first one is plus or minus 1. And the deviation of like 7 is plus 3. And then 4 to 1 is minus 3. There's no formula for this one. We're just eyeballing it for this particular one. But if you're talking about the standard deviation formula, the one where we're taking the deviations and then dividing by n, this one we're just eyeballing. Is that what you mean? That formula where we're taking the standard deviations and divided by n? And n minus 1. No, you're not confused. We were on these, we're just kind of eyeballing it. And so the logic behind it being about 2 is this here. So your mean is 4. Here's your mean. And you have, oops. Okay. And the straight mark is getting on my nerves. Let's remove that. So each of the 8 entries has a deviation of plus 1 or plus or minus 1 or plus or minus 3. So here you're 1 away, and here from 4 to 7 you're 3 away. That's plus, and this is plus 1. So if you go the other way, 4 to 3 is 1 standard deviation to the left away, and then from 4 to 1 you're 3 standard deviations to the left. And so the population standard deviation would be about 2 because that's in between the 1 and the 3. And I don't think, let me just see if I have a question here associated with this particular slide. No. I don't think you're going to have to do that in the homework. I don't believe I saw that there. But that's just an exercise for us. Okay. Interpreting the standard deviation. What does it mean? When the distribution is symmetric or bell-shaped, the standard deviation has the following characteristics. About 68% of the data lie within 1 standard deviation of the mean. 95% lie within 2 standard deviations of the mean. And 99.7% of the data lie within 3 standard deviations of the mean. Let me see if I've got a graphic coming up here. Yes, I do. Here you go. So what do they mean? Here's the mean. Down here at the bottom, and 1 standard deviation away to the left is x minus a standard deviation, and x bar, the mean minus the standard deviation, and then to the right is x bar plus the standard deviation. So 68% of your data is within 1 standard deviation from the mean. So that means 68% of your data points are within 1 standard deviation of the mean.
It's okay.
Still teaching. Okay. Within 2 standard deviations of the mean is 95% of your data. So if you think to yourself, I have 100 data points, 95 of them are going to be within 2 standard deviations of the mean. And then within 3 standard deviations of the mean, it's 99.7% of your data. So that's a lot. So what we say is a point is unusual if it's more than 2 standard deviations away from the mean. A point is unusual if it's more than 2 standard deviations from the mean. Okay. In a survey conducted by the National Center for Health Statistics, sure I have a question that goes along with this. The mean height of women was 64.1 inches with a sample standard deviation of 2.6 inches. Estimate the percent of women whose heights are between 58.9 inches and 64.1 inches. So let's look at this. You have 64.1, and you're going to subtract the standard deviation, what was it, of 2.6 from 64.1. Once you do that, you get 61.5. And then you subtract another standard deviation from the first one, so 2.6 subtracted from 61.5 gives you 58.9. And we just keep going on out to the left, and then you keep going on out to the right by adding the standard deviation. So what they asked was, what percent of your data is between 58.9 and 64.1? Well, that's going to be 13.59 plus 34.13. Because remember, in here, this was 68%. So this part here is 34. And then this part here is about 13.5, which is what they have on the screen. But if you do the calculations yourself, or you look at 95, this being 95, and you subtract away 68, you can do the math to get into that little area right there. Do they have it here? Let me see. Yeah, they do. They do on your graph. So 2 standard deviations away, they got 13.5 and then 34. It looks like they just got a little more precise on this particular slide. So how much of your data is in between there? 34 plus 13.5. Which is 47.72% of your data is in between 58.9 and 64.1 inches. Okay. Now, let me make sure I didn't have a question that was associated with. Okay, so we get back into the frequency distributions and a sample standard deviation for a frequency distribution. Here's our formula again. You have the data point and its deviation from the mean. Then you're going to square that and then add them all together. Then you multiply that by f, the frequency. And then you divide by n minus 1. And take the square root of all of that. For the standard deviation, the variance is not the square root. When a frequency distribution has classes, estimate the sample mean and standard deviation by using the midpoint of each class. So we, on this first example, don't have classes. So it's just going to be 0 through 6. It says find the sample mean and the sample standard deviation of the data set. Now, let's look and walk through the process. Remember the sample mean from what we had before. We're going to multiply the number by its frequency and then divide by the number of points in the data set. That gives us about a 1.8, and that's what we did in the last section. Now, here's where you have a lot of calculations. And it's got 145.38 is the sum of our deviation squared times the frequencies. And then 50 was our number of points in the data set. So 50 minus 1 is 49. So the standard deviation in this case is about 1.7. Okay. And that's just showing you the calculations. You're going to have, you can do this in StatCrunch. All right. Using midpoints of classes. Let's walk through a couple of, I think, okay, we're almost We're almost at the end. Let me see if there's a, yeah. All right. The figure shows the price ranges and corresponding number of homes recently listed for sale in a mid-sized U.S. city. Notice they have from 400 to 499, from 300 to 399, and they've got the frequencies listed there as well. At the end, you're going to have an open-ended class. And let me show you what that looks like. So here at the bottom, you see this open-ended class. Well, you're going to have to establish, and they're going to give you the number in your homework, but we're going to use 599.5, and they'll give you that. You don't have to guess what that's going to be. It'll be given. Okay. So X times F, and then we add all those together to get the sum. Divide that by N, which is 390, and our sample mean is 154.5. Then we go through, and for each class, we're going to take their deviation and then square that deviation and then multiply that times the frequency and get the summation of that, which is 7,557,750. I'm not sure why this extra square root symbol is there. It's not supposed to be there. And then we'll divide that by 389 because the total was 390. Remember that? That was 390. And we'll get 139.4. So let's look at question 10. And we're in 2.4, question 10. Okay. The distribution of the tuition fees and room and board charges of a random sample of public four-year degree granting post-secondary institutions is shown in the pie chart. Okay, so what I'm going to do is I'm going to give you some guiding principles here. We're going to use, does it tell you? It doesn't. It doesn't tell you. Yeah. Do we have classes? Did they give us classes here? Yes. Okay. So you'll calculate the midpoint of each class, and you're going to put that in the X field. And then you're going to put the frequency there. And they give you the frequencies in this table. So here's the midpoint. Find the midpoint of 17,499, and its frequency is 9. And the reason I'm running low on time, I wanted to get a little bit into 2.5. At the top of the range, like right here, like I was telling you before, they're going to tell you what to put in there. So 26,249.5 as the midpoint for 25,000 or more. Let me show this completed. There we go. So here's what this kind of looks like here. Do I have any notes on this? That's it. All right. All right. So question 10 and 11 is the same. Let's see, classes. Find the mean and the approximation for the sample standard deviation. Okay. So there's things we've done already and we've done before. So let's move into coefficient of variation, and then we'll touch 2.5. We'll touch 2.5. We won't get all the way through it because it's already 9:20. All right. The coefficient of variation, it is going to describe the standard deviation of a data set as a percent of the mean. So we'll take the standard deviation, divide it by the mean, and then we'll multiply that by 100%, 100 to get the percent. And the sample data set and population data set is about the same. Sample standard deviation is S. Sample mean is X bar. The sigma is the population standard deviation, and the mu is the population mean. All right. So here, this table shows the heights and weights of the members of a basketball team. Find the coefficient of variation for the heights and the weights, then compare the results. So what they're going to do is they're going to find the standard deviation and the mean, divide them by each other, and multiply by 100. So let's look at that. The mean height, and for you, what you can do is put it in StatCrunch, of course, just the double window, open in StatCrunch, the summary stats to find the mean and the standard deviation. And then you'll multiply that by 100. So 72.8, 3.3 divided by 72.8, which is the mean, multiply that by 100, and you get 4.5%. Same goes for the women. Was it women and men? Let me go back. No, heights and weights, not women and men. I think I'm on next slide. Next section. All right. So in this case, we have 17.7 divided by 187.8. And again, you will calculate these things in StatCrunch, then you'll find the coefficient of variation. The weights at 9.4% are more variable than the heights at 4.5%. So the bigger it is, the more variation there is, the bigger that percentage. Okay, that ends 2.4. That ends 2.4. I just want to make sure that I don't have any questions that I wanted to do with you in the homework. Or sometimes I'll put it in my notes. Okay. No, let me move on. Let me move on. 2.5. And 2.5 is a shorter one. We're talking about measures of position this time. We're going to be looking at quartiles. We're going to be looking at percentiles. Something flying in the face. Okay. Okay. Last 25 minutes. Fractiles are numbers that partition or divide the ordered data set into equal parts. Okay. Quartiles, we divide into 4 equal parts. Quartile, quarter is a fourth of a dollar. So the first quartile is going to cover the first quarter of data. The second quartile we call the median, and that's going to cover the first half of your data. And then the third quartile is going to cover 3/4 of your data. All right. So let's find in this data set the first, second, and third quartiles of the data set. So how many data set numbers do we have? 15. So 15, that means the median is right in the middle because it's an odd number. And we learned that earlier today. Then we have the lower half. We need to find quartile 2 in this, which basically is going to be your median of the first half of your data. Quartile 2. About 1/4 of the countries have 10 or less. About 1/2 have. Oh, is this not an even number, is it? 1, 2, no, that's 7. Ah, that's why quartile 1 is. If you have an even number in between in your lower half, you're going to have to take the average of the 2 middle ones. So just keep that in mind. It's like finding the median of the lower half and the median of the upper half. I'm going hoarse. I guess that's what happens after 3 hours. Quartile 1 is 10. Quartile 2, upper half, the exact middle of the upper half is 31. So about 3/4 have 31 or less. Then we talk about what's called the interquartile range. That's Q3 minus quartile 1. And we kind of use this to find if a data point is unusual or not. But we won't do that today. We have what is called a box and whiskers plot. And you may have seen one of these before. See at the bottom? Your minimum entry, the minimum data point is going to be a whisker at the end of the whisker. Quartile 1 is going to be the start of the box. The median is going to be within the box. Quartile 3 is the end of the box. And then the maximum is going to be the final whisker at the end of the final whisker. And you can draw the box and whisker plot that represents the 15 point data set here. Let's do this in StatCrunch, just so you can see how we form a box and whisker plot. $18, $19, $20, $31, $54, $59, $4. Okay, so graph, box plot, and I think I put that stuff in bar 2. See what my options are. You can mark the median if you want to. You can mark the mean if you want to. And StatCrunch puts your box plot vertically, but if you want to draw it horizontally, you can select that option. Okay, now what StatCrunch does for you is it identifies your outliers for you. Okay, so 104 is pretty much farther away from the other points in the data set. So in StatCrunch, it will identify that this is an outlier by putting the point outside of the whisker. In this case, they just drew it in. into the whisker as the maximum data point. Okay. A couple of things. Quartiles divide the data into 4 equal parts, deciles 10 equal parts, and percentiles is going to be 100 equal parts. And we're used to working with percentiles. Let's look at. Let me look at 2.5 question 1. I have a note to myself to look at that. Oh, okay. A motorcycle's fuel efficiency represents the 9th decile of vehicles in its class. Make an observation about the motorcycle's fuel efficiency. And remember, deciles divides the data into 10 equal parts. So which one, get rid of that. Is going to represent the fuel efficiency of this motorcycle. I was trying to get back to the chat. What do you think? A, B, C, or D? The 9th decile. Got 2 B's. Lots of B's. Correctamundo. That is 90%. Okay, let's look at question 2 before we get into the OGIV charts. It says, find the quartiles, find the interquartile range, and then identify any outliers. So here is our chance to do this in StatCrunch. So open in StatCrunch. Graph. Box plot. var1. Compute. Yes, it's just 90. Not 91 or 92. When we're talking about the deciles. Oop. Options. Edit. I want this to be, show me the median, and then draw the box horizontally. Okay, so one of the things that I was telling you earlier was that if you hover over the graphs in StatCrunch, they give you information, right? So in this case, quartile 1, I'm hovering over the box itself. It gives me all of them. I thought I had to hover over the median. Well, the median is 59. That's the second quartile. The first quartile is 56. The third quartile is 64. Find the interquartile range. That's 64 minus 56, which is 8. Q3 minus Q1. Thank you, Avery. Choose the correct answer below. There exists one outlier in the data set. Let's see. Is this which one is this? How many StatCrunch windows do I have open? Is this the one we're working with? Yeah. So here's our outlier at 83. I didn't see any. Oh, So let's identify that outlier as 83 because it's that point that's sitting off to the side. And then you do it again for question 4. So here on question 4, they're telling you to identify each piece of this box plot. So remember, we got minimum, quartile 1, quartile 2, or the median, quartile 3, and the maximum. So the quartiles are not too bad. Identify the 5-number summary. Here's a good one. Use the box and whisker plot to determine if the shape of the distribution represented is symmetric, skewed left, skewed right, or none of these. Most of the data points are going to be in the middle between quartile 1 and quartile 3. What do you think this is? Skewed left, symmetric, or skewed right? Okay, Christopher. That's awesome. That was quick. We got 2 skewed rights. 2 people think they're skewed right because the tail is longer, right, on the right side. So let's try it. Nice work. Okay, so we won't continue that. We will go back to the PowerPoint. You kind of get what I'm saying with the quartiles. And if you draw the box plot, lost my train of thought. If you draw the box plot, you can hover over and get all the quartiles. And you know how to find them by hand as well, if you want to do that. All right, so we have an OGIV chart. It is used in statistics to show cumulative frequencies. So this OGIV chart, how we read this, the scores are along the x-axis and the percentile is along the y-axis. What test score represents the 62nd percentile? Well, we need to kind of draw a line to the 62nd percentile to its respective score. So that corresponds to the 1600. So 62% of the students had an SAT score of 1600 or less. Okay. 937. Okay. So we get into something else, and that's all we're doing with the percentiles there. I think this particular section is more straightforward than some of the other ones we've had. Like if you think about standard deviation, it was pretty kind of heavy in that if you're doing them by hand, it's a lot of steps to remember. But this particular section, I think is all right. Let me look at question 10. Let me just look at question 10. Okay. We got a little chart here. The 60th percentile represents about how many inches? Can you see that? About how many inches would that be? 70? Okay. Yes, 70 for the 60th percentile. See, these are not. Oh, A, B, C, or D. This means about 60% of the males aged 20 to 29 are shorter than this height or taller than this height or exactly this height. A, B, C, or D. We can look back at the interpretation here. This means that 62% of the students had an SAT score of 1600 or less. Have anybody else? Only Avery wants to wage a guess there. So on B, they have 40%, and that's it still says shorter, but it's 40 instead of 60. Yeah. Don't let them fool you. All right, so shorter was it. Now, let's get into Z-scores. Very important VIP in the last 9 minutes of class. The standard score represents the number of standard deviations a given value X falls from the mean mu. So how do we standardize a score or produce a Z-score? Where we're going to subtract the mean from the value and then divide that by the standard deviation. That's our formula. So here in 2009, Heath Ledger won the Oscar for Best Supporting Actor at age 29 for his role in this movie. Penelope Cruz won the Oscar for Best Supporting Actress at age 34 for her role in that movie. The mean age of all Best Supporting Actor winners is 49.5, standard deviation of 13.8. Mean age of all Best Supporting Actress winners is 39.9 with a standard deviation of 14. Find the Z-score that corresponds to the ages of Ledger and Cruz. So it's on the next page, but just to pull out the information here. You have X, so 29, and minus 49.5 all over 13.8. Because this is the standard deviation. And the mean age here. And then you're going to do the same thing for the Best Supporting Actress. So that would be 34 minus 39.9 all over 14. And then we'll compare our results. So Heath Ledger is 1.49 standard deviations below the mean, and Penelope Cruz is 0.42 standard deviations below the mean. So she's a little bit closer to the mean than he is. Both Z-scores fall between -2 and 2. So neither score would be considered unusual. Unusual, again, is -2, more than 2 standard deviations away from the mean. That would be unusual. Compared with other Best Supporting Actor winners, Heath Ledger was relatively younger, whereas the age of Penelope Cruz was only slightly lower than the average age of Best Supporting Actress winners. And that's how we do that. Let's look at 2.5, question 17. All right, this is a big example. So we might not get through it all,